Okay. Hello, everyone. Welcome to week 5 or week 4. Excuse me. I was reading the chapter number. So, week 4, we're going to be talking about decimals. So, decimals are really nice. Um, they're a lot more preferable than fractions because obviously, as we talked about last week with fractions can be a little deceiving, but not with decimals. And again, the best part about decimals is at the end of the day, we have a great real world example to follow, which is money. So again, if you ever kind of get stuck with decimals or anything like that, money is the best representation of a real life application of decimals. So let's go ahead and build a foundation. And of course, just like with the last previous chapters, we're gonna build some foundation, learn some stuff about decimals, and then also talk about how we work with the 4 operations. Okay. So the decimal system provides another way to represent whole numbers and their fractional parts. So remember, we're not always going to have a whole number. So, for example, we need things to represent. Well, what if you have $3.75? That's not a whole number. We can't just say 4, we can't just say 3 because we have this fractional remainder, these leftovers we have to worry about. And decimals are just another way to represent it. And again, as I mentioned, they're a lot easier and nicer to work with than sometimes fractions. But obviously, fractions also hold their purpose when need be. Okay. So back in week 1 or week 2, I think it was week 1. Yes, week 1. I discussed how when we were first building a foundation for just numbers in general, we talked about how to express numbers within words. Remember, I said that we have to refrain from using the word and. So when you're reading a long number, naturally your brain just wants to take a pause, hence the word and comes into play. But we have to be very cautious because mathematically and means something. And that's what it now is coming into play. So when writing decimals as numbers with words, specifically decimals, the word and, that's what's going to that's what's going to replace the decimal point. So that's why, again, in the beginning of week 1, when we were just learning about whole numbers and integers, we couldn't say the word and because, again, the and has some meaning. It's not just some buffer word. It actually has some meaning here. And again, that's what's going to take place of the decimal. Okay, so let's look at an example. So the number, we have 1,542 point. So notice there's this decimal spot. So this isn't a whole number. There is a fractional part to it, which is this change here, which this is the piece that is less than 1 or less than a whole number. So here we have 1,542, and this is where we would say and 500. Wait, what am I saying? Oh, sorry, I just blanked. 567 thousandths. So one thing I will say, after the decimal point, so here's where we have our whole numbers. So anything greater than 1 to the left. To the right is where we have values less than 1. This less than 1 after the decimal point has their own names because obviously we don't want to say, or I should say own place values. So obviously we don't want to say ones, tens, hundreds, thousands, stuff like that because again, those have meanings for whole numbers and integers. So what we talk about with values less than 1 when it comes to the decimal place, that's where we have tenths, hundredths, and I'm pretty sure in the book you could see a whole chart, thousandths. But notice the key difference is that TH at the end. So that's to help us represent that now we're talking about to the right of the decimal spot, which again represents values less than 1. So notice here, again, we have the THs. So, and of course it goes so on and so forth to 10 thousandths, 100 thousandths, so on and so forth. Okay. Let's look at this example. Let me reveal it. Okay. So notice it's not too much different than what we were doing. So first, again, we just want to say the number value. So again, we look at all the place values. So we have 1,000. Remember we talked about periods. So after every 3 numbers, we have something we call a period. So there's only one value within the thousands period. So then we say 1 period value, so 1,000. Now we move on to the hundreds. So 542. And remember, after the ones period, we don't say anything. So we don't say, 542 ones or anything like that. That's the only period we don't say. But again, there's a decimal point here. So this is where the word and comes in. You have to remember that that's now where we're taking this pause that we can go ahead and use. So we have 1,542 and what? Well, we still say the number the same. So 567. But again, now we look at the last value. So remember, it was tenths. Oh, my hand slipped. Hundredths. Thousandths. And then again, as I mentioned, so on and so forth with, they just follow the same place values, just backwards and adding a TH. So the 7 is in the thousandths. So again, you have to make sure to verify and clarify which place value that's actually in. Okay. Let me remove this. So to write a decimal number, write the whole number part to the left of the fraction point. So again, this is what I mean. This is the whole number part. This is, again, you can think of like your bills. Everything else to the right of the decimal, that's the spare change, if you want to think of it like that. Then write the decimal fraction part to the right of the decimal. So again, everything to the left, that's greater than 1. Everything to the right is less than 1. So that's how we show that fractional remainder. And then, of course, we use zeros as placeholders. So what do I mean by that? So for example, if we have 1,047, 508, we'll say. Notice the 0 is a placeholder. So we don't have anything in the hundredths place value, but again, we still want to show it because that is not the same if we just have 58. So we want to make sure, of course, to use 0 as placeholders. Okay, so let's look at some examples. So write 6 and 5/10 in decimal form. So we just got to see what we have here. So that's the nice part. When we look at how to now say fractions in terms of decimals, we just really have to see, well, what do we have? Notice I have 6 ones. So that's the whole number part that we talked about. So remember, whole number parts, that goes to the left of the decimal. So that's something that we're going to have to keep in mind. And then if we look at the fractional part, notice, well, what do we have? We have 5/10. So that implies that when we are starting to build our fraction, so we know we'll have 6 as the only whole number. So then we need that decimal point to break up the whole number in the fractional part. And then this 5/10 is implying where this 5 will be in the place value. So it's saying it's going to be in the tenths. Well, the tenths is immediately after. So that implies that this will then look like 6.5. So again, that's the nice part. Whatever whole numbers we have, that will go to the left. And then the decimal part, we just have to look at, well, what is it out of? So again, in this case, it's telling us that it's in the tenths place value. Okay. And what do we think about this one? So again, we have our whole number and our fractional part. So again, here we can see we have 5. This is a mixed number. So we sure have $5, but how much change do I have? So we know that we're going to have 5 to the left, so that's our whole number. But again, this one's a little bit trickier because what the fractional remainder part is telling you is, again, whatever it's out of, that's the place value that we're at. That's like the last, or I should say that's the last number. So here we have 67. Whatever is the denominator, that is where the last digit will be. So the last number represents which place value you ended at. So we have 5 point, because again, that's the only whole number we have. Now we're looking to the right. It's telling us 67 thousandths. So this is where we have to make sure to use the third step of having 0 as a placeholder, because again, what this is implying is the last digit has to be in the thousands. Well, remember, it's tenths, hundredths, I'm just going to abbreviate, and thousandths, but we only have 67. So that implies we need a 0 in the tenths, a 6 in the hundredths, and a 7 in the thousandths, again, because we want to make sure to show that we are having our last digit in the thousands. If we don't have this 0 and we just have 5.67, well, then this would be out of the hundredths. So again, we have to be careful about that. So here we can see we have 5 ones, 0 tenths, 6 hundredths, and 7 thousandths. And then we just got to go ahead and combine all the pieces. So not too bad, but you got to be careful on this tricky part here, because again, you want to make sure you're accurately representing what this fraction is saying. Okay, so comparing decimals is much easier than comparing fractions, because again, there's no kind of tedious least common denominator step or anything like that. As I mentioned, decimals are a lot more straightforward than fractions. That's the best way of saying it. So to compare, we first want to look at the whole number part. So basically, when we're comparing decimals to see which one's larger or what's the relationship between decimals, you're just comparing place value by place value. So we first look at the whole number. If we can tell that, okay, a whole number is bigger than the other, then we can go ahead, just answer it. But if the whole number is the same, then what are we going to do? We're just going to move on to the next place value. And then we're going to keep going to the tenths, to the hundredths, to the thousands, so on and so forth, until we finally have different numbers that are able to be comparable. Okay, so which is larger, 4.27 or 4.02? So again, first of all, we have to make sure to answer it correctly. So which one is larger? We want to look for the bigger number. And so we start with the whole number. Well, they're both 4s, so there's nothing to compare right now because they're the same number. So again, we move on to the next one. So notice we have in the tenths a 2 and a 0. Well, we want to know which one's larger, so this is where you just have to recognize, well, 2 is the larger number. So, and again, this is where money can come into play. If you have $4.27, well, you have more money than $4.02. So again, that's always the best part about decimals, is that you can go ahead and think through with the application of money. So in this case, we can see that 4.27 is the bigger decimal value. So again, just go step by step. But again, sometimes these are the type of examples that can be super easy that you make a really tiny mistake, like a simple mistake. So again, be careful. Make sure you're going just step by step. Don't rush through it, because again, it's just a presumptually easier problem. It's still easy to make a super small mistake. Okay, and now we have which one's larger, 0.0542 or 0.0524. So again, they're purposely going to put numbers super close to one another because they recognize that someone is going to skim through and make a mistake. So again, just go step by step. Well, we have a 0 here, 0 here. There's no whole numbers. Both of these decimals are less than 1. Well, in the tenths, a 0 and a 0. Nothing to compare. We're still at the same thing. In the hundredths, we have a 5 and a 5. Still nothing to compare. So again, notice we're just moving on. Well, now in the thousandths, we have a 4 and a 2. Well, who's the bigger number? Well, 4 is bigger than 2. And if we want which one is larger, then we can see that 0.0542 is then overall the larger number. But again, be careful, because notice it's just the slightest difference. And if you're taking a test or anything like that, you're a little bit nervous, little stuff like that, you'd be amazed, can trip you up. Okay, let's do one more, and then we'll move on to the next video. Now we want to round decimals. So rounding decimals, again, is super nice because it's the same concept of rounding that we talked about in week 2. So there's just a few more steps that are different. So to round decimals, the rounding principle, that doesn't change. The way we round, that stays the exact same. You identify the place value that you want. Remember, that has to be told, because you can round a number differently depending on the place value. You can change a number any way that you want. So again, that has to be in the instruction, to which place value do you want to round to. And then from that point, remember, if it's 5 or more, we increase it. If it's less than 5, then if it's less than 5, then we keep it the same. But the piece that differs is once we round, so when it comes to a decimal, once we round the given digit, we drop all the digits after it. So you'll see what we mean after that. So again, truly what I mean, drop. So they're not going to be in the final answer. Okay, so we have round 5,683 and 0.9, so 9 hundredths. to the nearest tenth. So again, first we identify, well, who is in the tenths place value? Here we can see we have the thousands, the hundreds, the tens, the ones, we're at the decimal point, the tenths, and the hundredths. So the nearest tenth, that implies that we want to focus in on the 0. Well, remember something's in my eye. We look at the place, we find the place value, we look at the neighbor. Well, what do we notice about the neighbor? It's in the category of 5 or more. So what is this 0 going to become? Well, now it's going to become a 1 because of the 9. But again, you drop all the values after your rounding point. So now that 0 is going to become a 1, and everything after that is going to be gone. So notice we have 5,683 and 1/10. So again, notice we got rid of that hundredths. Again, you drop everything after. And again, that's just technicality. That's just, someone made that a rule. Okay, now we want to go ahead and round this number to the nearest hundredths. Remember, we want to identify, well, who is even in the hundredths? We have the tenths, the hundredths, the thousandths, the 10,000ths. So here we can see we have 5 in the hundredths. So from that point, we look to the neighbor. It's a 6. It's in the 5 or more. So that means that 5 is going to become what? A 6. But again, everything after the rounding point will be dropped. So then at that point, our number becomes 767 and 4600. So again, notice everything after the rounding place value has been dropped. And that is it for our first video. We're going to go ahead and then talk about some fractions and decimals, and then go on from there. Enjoy the rest.